So today we are gonna start with a most important topic, measure. Okay, so measure. So what is measure? So first let X as be a measurable space. Okay, so then what is measure? A measure is a function, and I denote it by mu from sigma algebra, and it takes value in 0 to infinity. So such that it will satisfy two property. Number one is measure of empty set is 0, and number two is measure of sum of k is equal to 1 up to infinity. Ek is actually sum of k is equal to 1 up to infinity measure of Ek, where Ek are countable pairwise countable disjoint sets in as they are pairwise disjoint. So this thing is very important, this word pairwise disjoint. Okay, this is very important. So this is the only important thing in this definition. Okay, so now to see we can have example. So example to better understand it. Okay, so example is I take my sigma algebra is power set. Okay, and let x belong to x, then we define measure of E is 1 if x belong to E, 0 if x doesn't belong to E. Then we want to show that mu is a measure. Okay, so if we want to show that mu is a measure, how can we show that? Very easy. So first property is we want to show that measure of phi is 0. So how measure of phi is 0? Because x doesn't belong to empty set. So there is nothing in empty set, so definitely measure of phi is then 0. Obviously. Okay. Now for the second, we want to show that measure of union of k is equal to 1 up to infinity. Ek is sum of k is equal to 1 up to infinity measure of Ek, where you must know that this condition will only satisfy whenever Ek are pairwise disjoint sets. Okay. Now because a measure we define takes two values, so first it take 1 is equal to 1 if and only if x belong to union of k is equal to 1 up to infinity. So if x belong to union of k is equal to 1 up to infinity ek, this means that there exists k such that x belong to ek. If something is in union, this means that there will be at least one set that element will belong. Okay, so now we know that ek are pairwise disjoint. So if x belong to Ek, it will exactly belong to one of the Ek. Okay, since Ek are pairwise disjoint set in S, so there exists unique, this is unique k such that x belong to Ek. So if there is only one k such that x belong to Ek, this means that what we can say, if x belong to Ek, the measure is Ek is equal to 1. Okay, so there exists unique k such that measure of this. Now if measure of Ek is equal to 1 for a unique k, what we can say about the sum? So sum of k is equal to 1 up to infinity measure of Ek is equal to 1 as well, because all other will be 0. Because all other measures of Ek is 0. Okay, and we show that. Okay, that okay, my union of k is equal to up to infinity, this is equal to this thing, and they have same value. and we can do that for other, because mu take two values. So now for similar thing we can do for okay, so now we need to show that measure of k is equal to 1 up to infinity ek is equal to 0 if and only if x doesn't belong to union of k is equal to 1 up to infinity ek. Now if x some element is not, if any element is not in the union, this means that x will not belong to ek for all k. And now since x is not in any of the ek, what we know, then measure of ek is 0 whenever x is not in ek. So this means that measure of ek is equal to 0 for all k. And clearly if measure of k is equal to ek is equal to 0 for all k, then we can write down this is also 0. Hence mu is a measure, okay, on measurable space. And then we are done. Okay, so I think that's it for today.